We're going to go over an example of how to solve rational equations. This is part 1 of section 1.6, and you see an example of a rational equation there on the left side of the screen. It's got fractions and variables in the denominator. So the three things you have to think about when you solve these is what can x not equal? That has to do with the fact we have a variable in our denominator. So in this particular equation, x can't be 5 because our denominator can't be 0. We have to think about what our common denominator is. And then once we solve it, we have to think about extraneous solutions. That is, solutions that we get that are correct algebraically, but because we have a fraction in this instance, sometimes we get answers that we can't use. So let's take a look at this example here. I've got 2x minus 3 over 2 plus 5x over x plus 1, and that equals x. So the first thing we want to do is consider what x cannot equal. Well, if we set our denominators equal to 0 and solve, we see that x equals negative 1. And that would make this denominator equal to 0. So x cannot equal negative 1. Now, our common denominator is typically a combination of each of the separate denominators. But if you can factor a denominator, you should do that, because a lot of times you'll have a combination of some denominators, and you won't see that until you factor that. Our common denominator then is 2 times x plus 1. Okay, so this fraction, 2x minus 3 over 2, has the 2 part, but it's missing the x plus 1 part. Now remember that x plus 1 over x plus 1 is equal to 1. So I'm not changing the value, I'm just multiplying it by the number 1 in disguise. Same thing here. This fraction has the x plus 1 piece of the common denominator, but not the 2. And over here, x, remember originally it was just x, so x over 1, it doesn't have any part of the common denominator. So we end up getting, if we multiply this out here, 2x squared minus 3x, minus 3x plus 2x minus 3, and that combines to this part down here, plus 10x equals 2x plus 1, or plus 2 times x, or 2x squared plus 2x. Now, I don't like fractions, so we're looking here at just the black equation. I don't want to work with fractions if I don't have to. So I'm going to multiply by 2 times x plus 1. Well, that means this will cancel. And if I multiply on this side by 2 times x plus 1, I need to multiply on this side by 2 times x plus 1. But again, that will cancel. And so now I have just an equation, a quadratic one, or at least it looks like a quadratic. However, what we'll notice is we're going to subtract 2x squared and subtract 2x to get everything on one side. So what looked like a quadratic equation turns out not to be a quadratic equation. We get 7x minus 3 equals 0. Add the 3, divide by 7, and we get a value of x equals 3/7. Now, if we go back and check, x could not be negative 1. Well, it's not negative 1, so that's A-okay. If you want to check your answer to make sure you don't get 0 in the denominator, you can, but we've kind of already taken care of it up here. So we have a solution, x equals 3/7.